This call is now being recorded.
So good afternoon, all my dear students. Again, we are going to start next topic of differential equation. In previous lecture, we discussed about the definition of differential equation, order, degree, and first order, first degree differential equation, and some methods of solving first order, first degree differential equation, which methods we saw: homogeneous linear differential equation, then variable separable, and exact differential equation. Yes. Then today we are going to discuss about the next topic of that differential equation, linear differential equation with constant coefficient. So first of all, we see here linear differential equation with constant coefficient. What is mean by linear differential equation with constant coefficient? Meaning of linear means in your given differential equation, order of that given differential equation is 1. So at that time we say that that differential equation is a linear differential equation with constant coefficient. Means every differential coefficient, there are some coefficients are there. Suppose here a0, a1, a2, a3 and so on. These are the coefficients, and d to the power ny dx to the power n is the differential coefficient. So order of that differential equation is 1. That's why we say that the given differential equation is linear differential equation with a constant coefficient. So what is the form of linear differential equation with a constant coefficient? So a naught d to the power n y dx to the power n plus a1 d to the power n minus 1 y dx to the power n minus 1 plus a2 d to the power n minus 2 y upon dx to the power n minus 2 and so on, which is equals to q. So here q is a just a notation, and q is a function of x. Means in this differential equation, right hand side is always in terms of x. So just we denote it as q. So what is the meaning of q? Q here, the term is in terms of x. We can also write this differential equation as here a naught nth derivative, here a1 n minus 1th derivative plus a2 n minus 2th derivative plus and so on. Here y as a common term, and this is equals to q. So this is the another form of that differential equation, where a naught, a1, a2, a3 and so on all are the constant, and your right hand side q is always a function of x. What is the meaning of q is always a function of x? Your right hand side is always in terms of x. Then here ddx. So here ddx means a capital D. ddx means capital D. So we have to denote this equation as a naught d dx means capital D to the power n plus a1 d dx means again capital D to the power n minus 1 plus a2 d dx is again capital D, so capital D to the power n minus 2 plus and so on, and into y equal to q, where what is d dx? Where d dx is d, and d is a differential operator, so we have to denote here d dx as capital D. So this overall equation is in terms of capital T. So in general, we have to denote this differential equation with constant coefficient as f of d. Means whole overall equation, just we have to denote this overall equation as f of d. What is the meaning of f of d? F of d means differential equation which is in terms of capital D. तो मैंने उसको in general denote कर दिया है f of d y equal to q. So this is overall about linear differential equation with constant coefficient. So students, ये सारी चीजें आपको इस टॉपिक में लर्न करनी है, क्योंकि नेक्स्ट जितने भी डिफरेंशियल इक्वेशंस आएंगे, हायर ऑर्डर डिफरेंशियल इक्वेशन, so there are some methods of solving higher order differential equation, that is Cauchy's homogeneous, Legendre's differential equation. So with the help of this concept, we have to solve linear Legendre's homogeneous differential equation. So f of d y equal to q, this is the general form of your linear differential equation with constant coefficient. So in next, there is one remark for you. When there are two types of linear differential equation. So which are these two types? First one is homogeneous linear differential equation, and another one is non-homogeneous linear differential equation. So what is mean by homogeneous and non-homogeneous? So f of d y equal to q, this is your general form of differential equation of any order when q equals to 0. What is q? Q is the right hand side which is in terms of x, which is a function of x, is equal to 0 in this general form. Then that equation is called as homogeneous linear differential equation. Yes. Then next one is non-homogeneous linear differential equation. Suppose when q is not equals to 0, means right hand side of that equation is not equals to 0 in this general form of differential equation, then that equation is called as the non-homogeneous linear differential equation. So there are some examples of linear differential equation with constant coefficient. D square y by dx square plus 2 dy by dx plus 3y equal to sine x. Why we called it as linear differential with constant coefficient? Here coefficient of the first term is 1, coefficient of second term is 2, and coefficient of third term is 3, and all these 1, 2, 3 are the constant terms, and degree of that differential equation is 1. What is the degree? I already told you what is degree. Degree means power of highest derivative. Power of highest derivative is called as the degree. So what is the degree of this differential equation? 1. And here coefficients are constant. That's why we call this equation as linear differential equation with constant coefficient. We take another example, d square y by dx square minus 2 dy by dx plus y equal to x square. Same here, this is the differential equation. So here again, d square y by dx square is the highest derivative, and power of that highest derivative is 1, means degree of that differential equation is 1, and coefficient of each term is constant. So here we call this equation as linear differential equation with a constant coefficient. Next is general solution or complete solution of differential equation. Every differential equation has a solution, but in this linear differential equation, general solution or complete solution of differential equation is complete a solution equal to complementary function plus particular integral. Means complete solution of linear differential equation is a combination of complementary function and particular integral. Means whenever we have to find out the complete solution, first we have to find out the complementary function and particular integral. So complementary function can be denoted as CF plus particular integral as PI. Then operator D, we already discussed in previous slide. Capital D, operator D, denoting here ddx, it is denoted by capital D. D square dx square, it is capital D square. D cube dx cube, that is capital D cube, and so on. So that d dx means capital D, d square dx square means capital D square. That's why we write here dy by dx equal to capital D y, d square y by dx square equal to d square y. We have to denote d cube y by dx cube as capital D cube into y. These are the notations we have to use in whenever we have to solve the differential equation. We use these notations. Means we have to find out the complete solution of that differential equation. Means we have to find complementary function and particular integral. So in next slide we have to discuss some cases of finding complementary function and discuss about some cases of finding particular integral. So this is the example, d square y by dx square plus 2dy by dx plus 3y equals to 0. Whenever we have to find out the solution, first we have to convert your given differential equation in terms of your operator capital D. So first of all, we see how to convert the given differential equation in terms of operator D. So d dx is capital D. So this is d square y plus 2 d dx is again capital D y plus 3y equal to 0. Y taking common here. So d square plus d plus 3 y equals to 0. Similarly, we see another example, d cube y by dx cube minus d square y by dx square plus 2 dy by dx plus 3y equals to 0. Again, we have to write down this differential equation in terms of operator D. So d dx is capital D. So this is capital D cube y minus here d dx is again capital D, so d square. Again d dx is capital D, so 2dy plus 3y equal to 0. In this differential equation, we have to write down y as a common term. So your equation is d cube minus d square plus 2d plus 3y equal to 0. I told you what is the complete solution of given differential equation. What is the complete solution of any given differential equation? Complementary function plus particular integral. This is the solution of complete solution of linear differential equation with constant coefficient. So in this slide, we discuss about the rules of finding complementary function. There are some rules, some cases of finding complementary function. So case 1 is if roots of the given differential equation are real and unequal. Unequal means different. If the roots are different. For example, suppose roots are m1, m2, m3, m4 and so on. According to the order of that differential equation, we get the number of roots. Suppose order is 2, we get 2 roots. Suppose order is 3, we get 3 roots. Suppose order is 4, we get 4 roots. So according to that roots, we have to write down the complementary function. So how to write down the complementary function for roots are real and unequal? Roots are m1, m2, m3. So write down here CF means complementary function equal to C1 e to the power first root into x plus C2 e to the power second root into x plus C3 e to the power third root into x and so on. This is the case first if the roots are real and different. So next case 2, roots are real and equal. Suppose roots are real and roots are equal. So m equals to m1, m1, m1. These 3 roots are same. These 3 roots are equal. So what is your complementary function? C1 e to the power first root into x plus C2 e to the power second root into x plus C3 e to the power third root into x. जैसे हमने unequal में किया है as it is equal में करेंगे, but there is a slight difference between the roots are real and equal and real and unequal. Here roots are equal, so write down here x. First root is m1, c1 e to the power m1x. Second time that root is repeated, so here write down x c2 e to the power m1x plus third time again this root is repeated, so here write down x square c3 e to the power m1x. Means suppose your root is repeated, so you have to write down x, x square, x cube, x to the power 4 and so on. Next, case 3. Case 3, roots are real, equal and unequal. Means it is a combination of equal and unequal. Roots are real, equal and unequal. So here see m equals to m1, m1, m2. Means m1, m1, these 2 roots are repeated and m2, this is unequal. So here apply the combination of equal and unequal. So complementary function equal to C1 e to the power first root into x plus. For this first root, second root is repeated. So write down here x C2 e to the power second root into x plus m2. This root is different. This root is different. So write down here x C2 e to the power second root into x plus m2. This root is different. This root is different. So write down here x C2 e to the power second root into x plus m2. This root is different. This root is different. So write down here x C2 e to the power second root into x power m2x. C1 cos beta x plus C2 sin beta x, and next is here C2 sin beta x, CF equals to e to the power alpha x, C1 cos beta x plus C2 sin beta x. Yes, then case 5, roots are imaginary but repeated. Roots are imaginary but repeated. Means roots are imaginary and repeated. Means you have to apply the case 4 2 times. How 2 times? Suppose first root is alpha plus minus I beta. And again root is repeated means alpha plus minus I beta. So apply case of imaginary to alpha plus minus I beta and same to the alpha plus minus I beta, but these 2 roots are repeated. So here first write down CF for alpha plus minus I beta. So e to the power alpha x, C1 cos beta x plus C2 sin beta x plus, again the root is repeated here. So write down here x. Because whenever roots are repeated, we have to write down here x. e to the power again alpha x, c1, c2. These constants are already completed here. So write down c3 cos beta x plus c4 sin beta x. These are the of finding five cases of finding complementary function. So in next, we have to see some examples on finding complementary function. The solution of this differential equation d square y by dx square plus dy by dx minus 6y equals to 0. Yes, again I tell you one thing here. Whenever we have to find out the complete solution or a general solution of given linear differential equation with constant coefficient, first you have to see the right hand side of that differential equation. Why we see right hand side of that differential equation? When right hand side of that linear differential equation with constant coefficient is 0, then we have to find out the complete solution equal to only complementary function. Again, I repeat same thing. When right hand side of given differential equation is 0, so complete solution or general solution is equal to only complementary function. But right hand side is not equal to 0. So what is your complete solution or general solution? When right hand side is not equals to 0, so complete solution or general solution is equal to CF plus PI. Means we have to calculate both CF and PI. But in this differential equation, right hand side equal to 0, it means in this differential equation only we have to find out the complementary function. So how to find out the complementary function? First, this is the given differential equation. First, we have to write down that given differential equation in terms of capital D. Capital D is a differential operator. D dx is capital D, so square of that term is d square y plus d dx is capital D, here y, minus 6y equal to 0. So in this differential equation, we have to write down y as a common term. So d square plus d minus 6, y as a common term equal to 0. Whenever we have to find out the roots of that differential equation, first find out the auxiliary equation. Auxiliary equation. AE means auxiliary equation. So write down auxiliary equation as put D equal to M. So this equation can be written as M square plus M minus 6 equal to 0. Here find out the roots of that differential equation. Here m आप ऑलरेडी ये पढ़ चुके हैं 8th-9th स्टैंडर्ड में हाउ टू फाइंड आउट द रूट्स ऑफ दैट इक्वेशन, हाउ टू फाइंड आउट द रूट्स ऑफ दैट इक्वेशन. बट अगेन I repeat the same thing. M square, M here 1 and minus 6. We have to consider two numbers whose addition or subtraction is 1 and multiplication of these two terms will be minus 6. You have to split middle term as addition or subtraction of these two numbers will be 1 and multiplication will be minus 6. So we have to select this number as 3 or minus 2. 3 and minus 2. So m can be written as 3m minus 2m minus 6 here equal to 0. So consider the combination of these first two terms and last two terms. From first two terms, we take m common. So here m plus 3 minus from last two terms, 2 taking common. So here is m plus 3. So m plus 3, m minus 2 equal to 0. Here a into b equal to 0 means a equal to 0 and b equal to 0. So m equal to minus 3 and m equal to 2. Here we see that Here we observe that these two roots, minus 3 and 2, both are different, both are unequal. So apply case 1. What is your case 1? Y equal to C1 e to the power first root into x plus C2 e to the power second root into x. So this is the complete solution of that differential equation. There is no need to find out the particular integral. Why? Because right hand side of that differential equation is 0. So complete solution is only complementary function. Again, I take another example of linear differential equation with constant coefficient. D square y by dx square plus 2 dy by dx plus y equal to 0. Again, we have to convert this equation in terms of capital D. So capital D square y plus 2 dy plus y equal to 0. Y taking common. Y taking common. So D square plus 2d plus 1 y equal to 0. First of all, we have to write down the auxiliary equation. For finding auxiliary equation, we have to replace d by m, means m square plus 2m plus 1 equal to 0. And the roots of that equation is m plus 1, m plus 1. So m equal to minus 1, m equal to minus 1, and here both roots are repeated, means we have to apply case number 2 when roots are repeated. So how to apply this case? Y equal to C1 e to the power minus x. This root is repeated. So here write down plus x C2 e to the power minus x. This is the complete solution of that differential equation. Again, right hand side of that differential equation is 0. Means we have to find out here only complementary function. Next. Another example is here d to the power 4y upon dx to the power 4 plus 8 d square y by dx square plus 16y equal to 0. Again, we have to write down this equation in terms of capital D. So d dx is capital D to the power 4y plus 8. D dx is capital D, so capital D square y plus 16y equal to 0. Here y taking common, d to the power 4 plus 8d square plus 16 y common equal to 0. See here, in first slide, I told you general form of differential equation. See here, this is f of d y equal to 0. First of all, we find out the auxiliary equation by considering f of d equal to 0. So auxiliary equation is put d equal to m to the power 4 plus 8m square plus 16 equal to 0. Again, how to find out the roots of that differential equation? We have to split 8. We have to split 8 in such a way that multiplication of these two numbers will be 16. कैसे सिलेक्ट करना है? आपको मिडल नंबर एडिशन और सब्ट्रैक्शन 8 आना चाहिए और उसका मल्टीप्लीकेशन 16 आना चाहिए. So 4 4s are 16 and 4 plus 4 8. That's why m to the power 4 plus 4m square plus 4m square, that will be 8m square plus 16 equal to 0. अब इसको दो पार्ट में डिवाइड करो, फर्स्ट टू नंबर्स एंड लास्ट टू. So here m to the power 4 plus 4m square. So in this two term, m square will be common and write down here m square plus 4. In last two terms, 4 will be common, 4 m square plus 4 equal to 0. So m square plus 4 m square plus 4 common, and m square plus 4 equal to 0. So this will be m square plus 4 equal to 0 and m square plus 4 equals to 0. So m square plus 4 equals to 0, roots are m equal to plus minus 2i, and in second term m square plus 4 equals to 0 means m is equals to plus minus 2i. ये बता देती हूँ m is equals to plus minus 2i कैसे आया है, ठीक है। यहाँ पे आपके पास है m square plus 4 equals to 0. So write down here m square plus 4 equal to here 0. So here write down m square equal to minus 4. M square equal to minus 4. So what is m? M equal to, yes, plus minus here plus minus under root of minus 4. Under root of minus 4. So what is under root of 4? This is equals to plus minus. This is plus minus. Minus 1 is here. Minus 1 means I. Yes. And under root 4 means 2. So m square plus 4 equals to 0. We get m is equals to plus minus 2i. And second equation is m square plus 4 equals to 0 means again m is equals to plus minus 2i. Here roots are imaginary and roots are equal also. So here first we apply the case 2 plus minus 2i. So here alpha plus minus I beta. Alpha is not available here. So alpha is 0. So alpha is 0. Alpha plus minus I beta. And beta is 2. Alpha is 0. So write down here e to the power alpha x means 0x in bracket C1 cos beta. Beta means 2. Beta x plus C2 sin beta x. Same here apply case of imaginary. So this root is repeated. So that's why we write down here x because roots are repeated. Again alpha plus minus I beta. Again alpha is not there. So consider it as 0. So e to the power 0x C1 C2 then C3 cos beta x means 2x plus C4 sin beta x. E to the power alpha x 0, sorry, e to the power 0x is 1, e to the power 0x is 1. So here C1 cos 2x plus C2 sin 2x plus x C3 cos 2x plus C4 sin 2x. Or this equation can be written as here cos 2x C1 cos 2x plus x C3 cos 2x plus C2 sin 2x plus x C4 sin 2x. This solution can be written as in this way, and again right hand side of that differential equation is 0. So your complete solution is only complementary function. So here CF means here write down y equal to C1 cos 2x plus x C3 cos 2x plus C2 sin 2x plus x C4 sin 2x, and this is the solution of that differential equation. This is another differential equation here. This is another differential equation. But in this differential equation, some initial condition is given in the question. Yesterday, I told you what is the use of this initial condition. What is the use of this initial condition? Use of this initial condition is to find out the value of constant in your solution. With the help of this initial condition, we have to find out the constant C. Here d square x upon dt square plus 6 dx upon dt plus 8x. Again we have to write down this equation in terms of capital D. So your equation is capital D square x plus 6 d dt is dx plus 8x equal to 0. Here x taking common, d square plus 6d plus 8x equal to 0. Whenever we have to find out the roots of that equation, first write down the auxiliary equation. So your auxiliary equation is replace d by m. So m square plus 6m plus 8 equal to 0. This is your auxiliary equation. Again, how to split the middle term? We have to select two numbers whose addition is 6 or subtraction is 6 and multiplication of these two terms will be 8. So these two numbers are 4 and 2. Addition is 6 and multiplication is 8. So we have to split 6 as m square plus 4m plus 2m plus 8 equal to 0. Here grouping of two terms, first two terms and these two terms. So from first term, m taking common, so answer is m plus 4. From these two terms, 2 taking common, so this is m plus 4 equal to 0, m plus 4 and m plus 4 taking common here. What is the remaining term? M plus 2. So m plus 2 equal to 0 and m plus 4 equal to 0. It means m equal to minus 2, m equals to minus 4. So roots are different. These roots are different. So what is the solution? C1 e to the power first root into t. Why t? Because dx upon dt. So your solution is x equal to some value of t. So C1 e to the power minus 2t plus C2 e to the power minus 4t. This is the solution of that differential equation. Yes, but next we observe that one initial condition is given here, x of 0 equal to 1 and dx upon dt equal to 0 at t equals to 0. So with the help of these two initial conditions, we have to find out the value of constant C1 and C2 with the help of this initial condition. So how to apply initial condition? Dx upon dt, meaning of dx upon dt, meaning of dx upon dt is x is a function of t. X is a function of t. So x is a function of t means what is the value of t? 0. What is the value of x? 1. Means first condition is x equal to 1 when t equal to 0. So can we apply here first condition? X of t equal to C1 e to the power minus 2t plus C2 e to the power minus 4t. This is your solution. But initial condition is x of 0 equal to 1. So x is equals to 1 and t equal to 0. Put x is equals to 1. X equal to 1. T equal to 0 means x of 0 equal to 1. C1 e to the power 0, e to the power 0 is 1 here, plus C2 e to the power 0 is again 1. So your equation is C1 plus C2 equal to 1. But in previous slide, second condition is given here, that is dx upon dt equal to 0. So we have to differentiate this equation with respect to t. So what is the derivative of x with respect to t? Dx upon dt equal to c1 is a constant term. Derivative of e to the power minus 2t is e to the power minus 2t into minus 2 plus c2 is constant. Derivative of e to the power minus 4t is e to the power minus 4t, and minus 4 will be minus 4 here. Then dx upon dt equal to 0 at t equal to 0. So we have to substitute this initial condition in this equation. So your equation is dx upon dt equal to 0, e to the power 0 is 1. So minus 2c1 minus 4c2. This is equation number 3. So after solving equation 3, get the value of c1 of c2 is minus 1. How we get these two values after solving simultaneous equation? कैसे करोगे simultaneous equation? यहाँ पे minus 2c1 है, तो यहाँ पे 2 से मल्टीप्लाई करो इक्वेशन को, और इन दोनों को ऐड करोगे तो c1 कैंसिल हो जाएगा. We get the value of c2. Yes, and next यहाँ पे minus 4 है, यहाँ पे 1 है, तो इसको 4 से मल्टीप्लाई करो, दोनों को ऐड कर दो, तो प्लस 4c2 माइनस 4c2 कैंसिल हो जाएगा, तो वी गेट द वैल्यू ऑफ c1. सो c1 is 2, c2 is minus 1. So your required solution is x of t equal to c1. C1 means 2 e to the power minus 2t. C2 means minus 1 e to the power minus 4t, and this is the required solution of that given differential equation. Yes? Next. These are all about how to find out the complementary function of given differential equation, or maximum time in GATE examination. One question will be asked on finding the complementary function. Compulsory one question will be asked in your GATE examination on finding the complementary function of differential equation. So in next, we see how to find out the particular integral. There are another some cases of finding particular integral. So today only we see two cases, case number 1 and case number 2 of finding particular integral. So first of all, the general form of particular integral is, what is the general form of differential equation? F of, yes, what is the general form of differential equation is f of d, means equation in terms of d, y equal to q, equal to q. This is the general form of differential equation. So what is the general form of particular integral? Particular integral is equals to 1 upon f of d into q of x, means right hand side, which is in terms of x. So first case is when right hand side of that differential equation is e to the power ax. E to the power ax means a is a constant term, just like e to the power 2x, e to the power 3x, e to the power 4x. So how to write particular integral? Particular integral equals to 1 upon f of d into right hand side, that is q of x. Q of x is e to the power ax. So here q in place of qx, यहाँ पे मैंने e to the power ax लिखना चाहिए था. In place of q of x, here is e to the power ax. So put d equal to a. In this case, put d equal to a. So particular integral is 1 upon f of a into, again here, e to the power ax. So replace d by a. After substituting or after replacing d by a, provided that डिनोमिनेटर विल बी नॉट इक्वल्स टू जीरो. इट इज द कंपल्सरी कंडीशन है कि डिनोमिनेटर आपका नॉट इक्वल्स टू जीरो होना चाहिए आफ्टर रिप्लेसिंग d by a. Then what happen if f of a equals to 0? This will be 1 upon 0, and 1 upon 0 means infinity. It means your answer does not exist. So in that case, when denominator equal to 0, so we have to write down particular integral as 1 upon, take the derivative of this f of d with respect to d and multiply by x into right hand side. Again right hand side is e to the power ax. So again apply the same case, replace d by a. Again, if denominator will be again 0, so again write down x as x square. Here x square into 1 upon, take the derivative of this term with respect to d into right hand side, and we have to continue this process. कब तक कंटिन्यू करना है? वी हैव टू कंटिन्यू दिस प्रोसेस अप टू द डिनोमिनेटर विल बी नॉट इक्वल टू जीरो. तब तक आपको ये प्रोसेस कंटिन्यू करनी है. सो वी टेक वन एग्जांपल ऑफ दिस केस. हियर क्वेश्चन इज, here right hand side is not equals to 0. Right hand side is not equals to 0 means what is the complete solution of that differential equation? Complementary function plus particular integral. But यहाँ पे सिर्फ आपको particular integral पूछा है, इसलिए हम सिर्फ particular integral निकालेंगे. So your equation is d cube minus dy equal to e to the power x plus e to the power minus x. So here this is case number 1, e to the power ax. What is a here? 1. What is a here? Minus 1. So here write down pi equal to 1 upon f of d into complete right hand side. This is e to the power x plus e to the power minus x. Again 1 upon f of d into right hand side. So right hand side is having two terms. So we have to multiply this 1 upon f of d to both the terms. That will be 1 upon d cube minus d into e to the power x plus 1 upon d cube minus d into e to the power minus x. So in here, what is a? Here what is a? A is 1. So replace d by a, d by 1. In second term, here a is minus 1. So replace d by minus 1, d by 1. So 1 cube minus 1 e to the power x plus 1 upon d is replaced by minus 1. So minus 1 cube minus d is replaced by minus 1. Yes, after solving denominator, what is the answer? Here 1 cube minus 1. So here 0. In second term, minus 1 cube is minus 1. So minus minus plus, here again term will be 0. It means your answer does not exist because after substituting, after replacing d by a, first denominator will be 0. Second denominator is also 0, means your answer does not exist. So in this case, we have to write down here multiply by x and take the derivative of this denominator with respect to d. So what is the derivative of d cube? 3d square minus derivative of d with respect to d is 1 into e to the power x. Again same thing is happen in second term. Denominator equals to 0 means squares does not exist. So again multiply by x and take the derivative of this denominator with respect to d. So derivative of d cube is 3d square minus derivative of d is 1. So again apply same case. Here a is 1 and here a is minus 1. So replace d by 1 and replace d by minus 1. So here x, replace d by 1. Here 3 into 1 square plus x, replace d by minus 1. So minus 1 square minus 1. Here 3 minus 1 is 2. Here 3 minus 1 is 2. So 1 x by 2 taking common. So x by 2 e to the power x plus e to the power minus x. This is the particular integral of the differential equation. But sometimes one option is given there. Here pi equal to x by 2 e to the power x plus e to the power minus x by 2. So this is the formula of e to the power x plus e to the power minus x upon 2 is cos hx. So sometimes option is there, particular integral is x cos hx. Yes. Next, same case. Here, first case is e to the power ax. This is the first case, e to the power ax. Again, question is find the particular integral. If your question is find the general solution, then you have to write down complementary function and particular integral both. But your question is find the particular integral, so you have to find out only particular integral. So particular integral d dx is capital D square plus 4d dx is capital D plus 3 y taking common equal to 3 e to the power 2x. This is case number 1, e to the power ax. So what is the value of a here? Value of a is 2. So pi equal to 1 upon d square plus 4d plus 3 into right hand side 3 e to the power 2x. So in this case, value of a is 2. So you have to replace this d by a. D by a. So particular integral is 1 upon d equal to 2 means 2 square plus 4 into 2 plus 3 into 3 e to the power 2x. So calculation is 4 plus 8 plus 3, this is 15. So particular integral of that differential equation is 1 by 5 e to the power 2x. So this is the particular integral for the case e to the power ax. Next, case number 2. See here case number 2. When right hand side, what is your right hand side? Q of x. When right hand side is sine ax or cos ax, means sine 2x, sine 4x, sine 8x, just like. So how to find out the particular integral of this term? Particular integral equals to 1 upon f of d square. F of d square into right hand side cos ax or sin ax. So in this case, you have to replace this d square by minus of a square. यहाँ पे देखो बेटा माइनस साइन बाहर है और a square टर्म अलग है, not minus का square. It is minus, write down minus outside and then a square. So here 1 upon f of minus a square cos x or sin x, again provided that after replacing d square by minus a square, denominator will be not equal to 0. In case denominator will be 0, so answer does not exist, means your case is fail. So at that time, multiply by x, just like previous case, multiply by x and take the derivative of denominator with respect to d into right hand side cos x or sin x. Again replace d square by minus a square. Again, suppose denominator will be 0, then we have to write down here in place of x, x square, and take the derivative of this denominator, and we have to continue this process. We have to continue this process up to the denominator will be non-zero. So we take one example on case number 2. Question is, again find the particular integral, not complete solution. Again find the particular integral. So particular integral is pi equal to 1 upon f of d. What is f of d? F of d means equation in terms of d. So 1 upon d cube plus d plus 1 into right hand side, that is sine x. Here sine ax. So what is the value of a? Value of a is 1. Value of a is 1. In this case, only you have to replace d square by minus of a square. I will repeat same thing. Only d square is replaced by minus of a square. But in this example, here is d cube. So how to write in terms of d square? Because your condition is only you have to replace d square. So d cube can be written as d square into d plus this d as it is plus 1 into sine x. So here a is equals to 1. So replace d square by minus outside. यहाँ पे अच्छे से देखो, minus sign outside में है, minus of a square, and this is equals to minus 1. So replace d square by minus 1. So minus d plus 1 into sine x. Here d minus d plus d getting cancelled. So answer is sine x. So this is the particular integral of the given differential equation. I will tell you last example of this case. Again, question is find the value of 1 upon d square into cos of ax. Again, this is case number 2. So pi equal to 1 upon d square plus a square into cos of ax. So replace d square by minus of a square. So here d square is minus a square plus a square into cos x minus a square plus a square getting cancelled. Denominator will be 0. So 1 upon 0 into cos x. Again, case is failure. So case is failed. At that time we write here multiply by x and take the derivative of denominator with respect to d. So derivative of d square is 2d, a square 0 cos ax. Yes, x by 2. What is the meaning of 1 upon d? D stands for, capital D means d dx. D stands for derivative, and 1 upon d stands for integration. So 1 upon d stands for integration. So 1 upon d equal to integration of cos ax into dx. So x by 2. What is the integration of cos? Integration of cos is sine x upon derivative of ax with respect to x is a. So this is the particular integral of that. Next, this is another question. Find the complete solution of the given differential equation. Right hand side is 0, and the question is find the complete solution. Complete solution means complementary function plus particular integral. Complementary function plus particular integral. But right hand side is 0. So there is no need to find out the value of particular integral. Means your complete solution is only complementary function, because the right hand side of that differential equation is 0. Again, this is another example to find out the general solution. Here, right hand side is again 0. Right hand side is again 0. So you have to find out only complementary functions. So here roots are m is equals to plus minus I. So alpha is not available here. So alpha is 0, beta is 1. So e to the power alpha x, c1 cos beta x means 1x plus c2 sin beta x. So thank you so much. If you are having any queries related to this topic, you can ask. Yes, anyone? Yes, anyone? Any questions? You are having any queries? कुछ क्वेश्चंस है आपको पूछना है?
No, ma'am.
No, ma'am.
No, ma'am.